For over 50 years, factor investing has promised a science of returns. Yet most published factors fail the moment real money is at stake. In a series of books and journal articles, Marcos Lopez de Prado has argued that, to become scientific, finance must change its current research paradigm, from associational to causal factor investing. The symptom is a replicability crisis. Researchers have cataloged hundreds of so-called factors, a sprawling factor zoo. On paper, the backtest soar. In live trading, the same strategies go flat. One study could replicate only 25 of 153 factors, and a flagship multi-factor index earned a sharp ratio of about 0.17, statistically indistinguishable from zero. Something is deeply wrong with how we validate these ideas. The root cause is a confusion between association and causation. Ice cream sales and drownings rise together, but banning ice cream saves no one. A hidden common cause, hot weather, drives both. It is a confounder. Causation is not correlation. It is what happens when you intervene. Julia Pearl's duoperator captures this. X causes Y only if setting X and breaking the arrows that point into it actually changes the odds of Y. Factor models make causal claims, yet they are argued with the language of correlation. Real science moves through 3 steps. First, the phenomenological step, you observe an association. Second, the theoretical step, you propose a falsifiable causal mechanism, X causes Y through some mechanism M. Third, falsification. Others design experiments to try to refute it. The trouble is that factor investing has been stuck at step 1, cataloging patterns without ever theorizing or testing the mechanism behind them. So a factor can be fake in 2 different ways. Taipei spuriosity is the factor zoo, pure statistical flukes born from p-hacking and backtest overfitting. These we can fight with multiple testing corrections. But type B spuriosity is subtler, and Lopez de Prado and Zunichind call it the factor mirage. Here the association is real, but the causal model is misspecified. And no p-value adjustment can save you from a mirage, because the numbers look perfectly sound. Misspecification comes from getting the causal graph wrong. Leave out a confounder, and you under control, suffering omitted variable bias. Control for a collider, a variable that 2 others jointly cause, and you over-control, injecting collider bias. As Lopez de Prado, Lipton, and Zunichind argue in the case for causal factor investing, the econometric canon actually rewards the wrong choice. Over-controlled models show higher R-squared and lower p-values, which makes them easy to publish and easy to abuse. This is not academic hair-splitting. It costs money. In causal factor analysis is a necessary condition for investment efficiency. The same authors show that a misspecified graph can flip the signs of the optimal portfolio. The result is that you end up buying what you should have sold, and vice versa. Same data, opposite sides of the trade. Even with perfect knowledge of means and covariances, a wrong causal graph turns profits into losses. What replaces backtest-driven guesswork? A causal research protocol. Select variables with honest, purged cross-validation. Discover the causal graph. Build the adjustment set with the due calculus. Measure causal explanatory and predictive power out of sample. Size positions on the estimated causal effects. Only then backtest with walk-forward and combinatorial cross-validation. And finally, deflate the Sharpe ratio for the many trials you ran. Compare the 2 approaches. The standard protocol is associational, p-value centered, and black box. Backtest until something looks significant, chase a p-value below 5%, and never state a mechanism. The causal protocol, laid out in Correcting the Factor Mirage by Lopez de Prado and Zunichind, instead discovers the graph, adjusts with the due calculus, tests the causal effect out of sample, and deflates the Sharpe ratio. It targets the mechanism, not the correlation. Can a machine learn this structure directly from data? Increasingly, yes. Algorithms like the PC method and LianGAM, guided by domain knowledge, can turn a tangle of unknown links into a directed graph, and even flag which variables are confounders, mediators, or colliders. In the ADIA Lab Causal Discovery Challenge, described by Olivetti, Zunichind, Yam, Lopez de Prado, Imbenz, and Hernan, the best solutions reached about 77% accuracy, far above the 40% baseline. So, can factor investing become scientific? Yes, but only if it grows up. Remember that association is not causation, that both statistical flukes and causal mirages mislead us, that a wrong graph can invert your portfolio, and that the cure is a causal empirical protocol. Draw your assumptions before your conclusions, and factor investing can finally become a science.